So this is just review from yesterday with all the key features. All right. So I'm going to call on people to answer some of the key features that we get from this graph. So let's go with Peyton. What's the direction of opening? It's opening up. Good. All right. Here. Elizabeth, what's the axis of symmetry? Okay, someone help her out. Jesse. So not just 2, but x equals. Right. So remember, it's an equation of the line, so you got to write x equals 2. And remember, the axis of symmetry is just the x value of the vertex. So what is the vertex? Well, Jesse. I just haven't. Good. Now, is that vertex going to be a max or min? Riley. It's a minimum. Good. What is the y-intercept? Roberto. Good. It's right here. So vertex is here. All right, what is one of the x-intercepts, Allison? Good. What's the other x-intercept, Abe? 3, 0. Good. So 3, 0. All right, now domain. What did you get for your domain? Here. Abby. Say one more time. All real numbers. All right, so the domain, you could have said negative infinity to positive infinity, or you could have said all real numbers. Either way, it's the same thing.
Could it be like positive infinity and negative infinity?
Nope. Got to be from least to greatest. All right, what's the range, Odin? So range is y value, so it'd be y is. And you got the -1 part, but it's not less than or equal to. It's greater than or equal to. Because all the y values we have graph are above -1. So you could also write this as from -1 to infinity. Either way, I would have taken either one of those. Any questions on the key features? All right. Now, for 2, they gave you y equals ax squared plus bx plus c, which is the standard form of a quadratic. All right. They asked you to put it in standard form and then tell you what a, b, and c are, which remember, a, b, and c are just numbers. All right. So if I put this in standard form, I have -x squared plus 5x plus 4. What's my a value? Anyone? -1, b, 5, c, 4. All right. Letter B. Now, if you look over here, do you see how y isn't by itself just yet? We have to get it by itself, so we need to add the 5 to both sides. So y is equal to x squared plus 20x plus 9. So what's a, b, and c? 1, 20, and 9. Then lastly, c, it's already in standard form, so we don't have to rewrite it. So what's a, b, and c? So there is no c value, so what do I actually put? 0. The reason I say put 0 is because you do need to know what a c value is. So if there's no c value, then nothing there, just put 0. Same thing like if there's no b value. If there's no b value, put 0 for b. All right, let's go ahead and get into notes for today. So if you got your Chromebook out, clamshell it. So today we are going to be talking about more about the standard form of a quadratic equation, and we're going to actually break down and show you how to get key features from the equation. So in other words, we're essentially going to learn how to graph a quadratic without a calculator. All right, and without having to just plug in numbers into the function to get a table. All right. So standard form is one of three forms that we will learn about in this class with a quadratic. Standard form is also the most common. All right. So standard form is typically y equals ax squared plus bx plus c. Now, a is always connected with the x squared, b is always connected to the x, c is always the constant. Always. All right. Just so you're aware, because what's going to happen is being able to identify those three letters or numbers or whatever will help you tremendously, one, with formulas. As you can see, we're about to learn a small formula, but when we get to quadratic formula, which is pretty extensive, you got to be able to identify those. So first off, we know that quadratic is a parabola-shaped graph. All right. Now, if you recall, the a value itself actually tells us whether the parabola opens down or up. So remember, if it opens down, that means you have a negative a value. If it opens up, that means, please stop talking, you have a positive a value. Now, axis of symmetry. We can actually find the axis of symmetry without actually looking at the graph or a table. Okay, so the axis of symmetry is given by this formula, x equals negative b over 2a. So if we take the opposite of the b value and divide it by twice the a value, that would give us our axis of symmetry. The y-intercept is just simply the c value. So whatever that c value is, that's the y-intercept. It's kind of like when you do y equals mx plus b with linear and how b is the y-intercept, it's similar to that. And then finally, the vertex. So with the vertex, obviously it's a point, but you take whatever you got for the absolute, the axis of symmetry. So that's negative b over 2a. That gives you the x. And then you plug that value back into the original function to get the y. So once again, this is the axis of symmetry formula. So if I ever ask you to find the vertex by hand, you first got to find the axis of symmetry because that's the x value. So you got to remember that formula, negative b over 2a. Once you do that, to find the full vertex, you find the y value by plugging in the x value back into the quadratic equation. So you'll take whatever value you got using that formula back into your original equation. So y equals ax squared plus bx plus c. And whatever you get when you evaluate using PEMDAS, that is your y value of the point. Guys, please stop talking. All right, so let's practice. So whenever I do any of these, I always start by identifying my A, B, and C, just so I know what it is right off the bat. So what's my A value? 1. So A, B, and C are always going to be numbers. All right, you'll never put letters in them. What's your B value? 0. All right. B is always connected to the X. If there's no X, you put 0. What about C? Negative 9. All right. So now that I can identify all of them, what's my y-intercept? Negative 9. Your y-intercept always comes from the C value. So C value automatically gives you your y-intercept. Now, for my axis of symmetry, I'm going to put it into the formula negative b over 2a. So what's b? 0. Now, since 0 is neither the positive or negative, we don't have to invoke the negative. All over 2 times what? 1. So this would be 0 over 2, which is just what? 0. So how would I write it, my axis symmetry? X equals 0. Now, that is also the x value of my vertex. So what do I need to do to find the y value? I need to plug this 0 back into the original equation and for x and evaluate. So I have 0 squared minus 9. 0 squared is 0, minus 9, that's negative 9. So this is one of the rare cases where the vertex is also the y-intercept. Doesn't happen too often, but it does occasionally. All right. Let's try another one. All right, A, B, and C. What's A? B? C. Y-intercept? 0, negative 5. All right. Yeah, you always start the y-intercept with 0 because remember, if you are on the y-axis, you have no x value. Or you have 0 as your x value. All right, negative b over 2a for axis symmetry. So that would be negative 8 over 2 times negative 1. So that's negative 8 over negative 2, which is what? 4. So how would I write my axis symmetry? X equals 4. That is also my vertex. Now, be careful when you plug the 4 back in, especially if you're putting it in your calculator. So when in doubt, put parentheses around the number that you're plugging in for x. All right, because technically, especially with this square right here, the negative is not going to be included in the square because it's already there. Meaning you take 4 squared and then multiply it by negative 1. All right, so what's 4 squared? 16. So since there's a negative still in front of it, we were going to make it negative. Plus 8 times 4 is 32, minus 5. So what is my y value of the vertex? It'll be 11. Now, why does this help us graph by hand? Well, vertex is, for one, the turning point of the graph. If you know where the axis of symmetry is, you can do reflections. And the y-intercept is usually just another point that you can then do a reflection to get a third point. So in reality, you can get 3 points out of doing this. The vertex, the y-intercept, and then the reflection of the y-intercept. All right. So try number 3. All I want you to do is just the y-intercept, axis symmetry, vertex. Don't graph it just yet. So don't graph, but just find the y-intercept, the axis symmetry, and the vertex. So again, always start by labeling A, B, and C. Even if you think you can automatically tell what it is, just to put your peace at mind, go ahead and just label it. Because trust me, it's more common than you think to misplace a number. So all you're doing, so all you have to do is take this B2, plug in. I'll just say I read it.
2 times negative 2, so it should be positive 2.
Positive 2.
Negative 8 divided by negative 2.
I know, whatever, but wouldn't it still be that same?
No, because this would be stay positive. Be plus 16. So graph and then find the y partner on the other side of the axis. It's not negative 2, you're going to do 2 times. You're not doing negative 2 times negative 2, you're doing 2 times negative 2. Yeah. Every x. All right, guys, one more minute. All right, check your answers. So I got 0, negative 3 for the y-intercept, x equals 2 for the axis of symmetry, 2, 5 for the vertex. Does anyone need me to go over how I got that? Any questions on that part? All right, so the next part's the graphing. So like I said, as long as you have a vertex and one other point, you can pretty much graph the parabola. So the vertex is at 2, 5, so it's right here. We have the other point, which is the y-intercept, so 0, negative 3. Now, we then want to find the y-intercept's partner. So remember, the axis of symmetry is actually a line of reflection. So if you count the distance away from the line of reflection that the y-intercept is, and do the same distance on the other side, that's its symmetrical partner. So now we got enough points to make an overall general shape. So the graph will look something like that. Does that make sense to everyone? All right. So number 4. A, B, and C, what is it? 1, 6, and 9. Y-intercept? 0, 9. So when I ask for the y-intercept, unless it's otherwise stated, I want as a point. All right. Negative b over 2a. So I have what? Set up the formula, but don't evaluate yet. Negative what? Times 1. So it'll be negative 6 over 2, which is what? Negative 3. So we write how? Negative 3.
That is also my vertex x value, sorry. Now, if I plug it back in, again, be careful with parentheses, especially like if you put -3 squared in your calculator, make sure that -3 is in parentheses. Otherwise, it'll take it as 3 squared times -1. So -3 squared is 9, minus 18, plus 9. So 9 minus 9 is -9, plus 9, 0. Now, we're going to take a minute and graph this. So I have my y-intercept at 0, 9. I have my vertex at -3, 0. And I know my axis of symmetry is right here. So if I want to find the y-intercept's symmetrical partner, I'm going to count 1, 2, 3, and then do 3 on the other side. So the parabola looks something like this. Remember, don't make it look like a V, because if you make it look like a V, it's an absolute value graph. You want to have a little bit of a curve to it. So don't just connect the lines, all right? Because if you connect the lines, it makes a V, not a U, and a V is an absolute value graph, completely different function. Now that we've graphed the function, what's the domain? All real numbers. So -infinity to +infinity. Now, remember, that's true for any quadratic function. So if I ever ask you the domain of a quadratic, that should be the easiest question you're ever asked, because it's always going to be all real numbers. Now, range depends on the vertex and whether it's a max or min. So is the vertex the max or the min here? It's the minimum. What part of the vertex am I using? What part of the vertex am I using for range? The y, so the 0. So I'm going to have 0 somewhere in here. Now, would the 0 come first or second in the interval? First, because it's the lowest. So we have 0, and we put a bracket because it is defined there. And it's going to go where? What's the highest y value? Infinity. And infinity always has a parenthesis. Yes, ma'am. Yeah. And remember, you could also write this as y is greater than or equal to 0. Oh, did you have a question?
I was just gonna ask if you could write it like that.
Yes, you can. So you can either write it. So guys, like I said yesterday, you can either write domain and range in interval notation or inequality notation, but you should be able to recognize both. Okay, because there may be a mix of that on your test, like say on a multiple choice question. All right, so make sure you recognize both forms. All right, now number 5. So any questions overall on finding axis of symmetry, y-intercept, and vertex, and then using that to graph the function? Any questions on that? It's pretty easy, right? Not too bad? All right. Now, 5. We're going to do a lot more of these tomorrow, but modeling with quadratics. More often than not, when they ask you questions about the quadratic, more often than not, a lot of it's just going to be a key feature. All right. Now, some of those key features we can use a formula for. So, like if this was your test and I gave you a problem like this, most likely you would just put it into Desmos and find whatever they ask you to find. But it's also a good practice to know how to do it by hand. All right. So the path of a ball is modeled by y is equal to -0.035x squared plus 1.4x plus 1, where x is the distance down the field and y is the height of the ball, measured in yards. And it wants to know what the maximum height of the ball is. So keyword right here, maximum height of the ball. Now, let's think about this logically. So if I had, just a general graph, someone threw a ball, so it probably started like wherever the hand height was. Someone threw a ball, it went up, 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 and then gravity takes effect and it comes right back down. All right. So they want to know what the maximum height of the ball was when you threw it. What key feature am I looking for specifically? You're looking for the vertex specifically. So that would tell us our max height. So we're looking for the vertex. Now, look at what they defined each variable in context. Specifically, what value of the vertex do I care about? The y value, because it says the maximum height of the ball, and it said y is the height of the ball. So specifically with the vertex, we want the y value. So this is where you have to use a calculator. Like, you don't need Desmos, but we can still do negative b over 2a to get the x value of the vertex. And whatever we get, plug it back in to get the y value. So if I label A, B, C, what's my A? Good. What's B? Not negative 1.4, positive. What's C? 1. So if I plug it into the formula, I got negative 1.4 all over 2 times negative 0.035. So someone in their calculator, what's 2 times 0.035, Odin?
0.07.
So 0.07, it's still going to be negative. All right, if you divide those two numbers, what'd you get? It's what? 20? Okay. So 20 is the x value. Now I got to take that 20, plug it back into the original function. So I have negative 0.035 times 20 squared plus 1.4 times 20 plus 1. So 20 squared is 400. What's 400 times negative 0.035? You get negative 14. All right. Plus, what's 1.4 times 20? 28. And then the plus 1. So negative 14 plus 28 is what? 14 plus 1, 15. So the y value of my vertex is 15. So the maximum height of the ball is 15 yards. So again, problems like that are doable by hand, but like, let's say this was like on a Math 3 EOC or something. Put it in Desmos. All right. Now, on your test, though, I can tell you right now, there is a part. So we broke the test up into 2 sections. There's the calculator active but no Desmos section, and then there's the calculator active Desmos section. All right. So make sure you do know how to do both. All right. Almost done. This is a quick lesson. All right. So now, number 6. First off, before we do anything answering, what should I do with my function? Put it in standard form. What would it be in standard form? Good. So, without graphing, do you think my vertex is going to end up being the max or the min of the function? Max. Why? Right. So it's the max because our a value is negative. Oops. Because our a value is negative, meaning it's going to open downwards. So it would look something like this. Now, max or minimum value, that is simply the y value of the vertex. All right. So we got to calculate the x value first to get the y value. So if I set this up just for time's sake, A, B, C, A is what? Negative 1, B, and C. So if I do negative b over 2a, I got negative times negative 6 over 2 times negative 1. What's a negative times negative 6? 6 over negative 2, which is what? Negative 3. So that's the x value of the vertex. Now I got to take that, plug it back into all the x's. So again, be careful with this. So I have negative, parentheses, negative 3 squared. So since that negative was already part of the original, even though the negative 3 is already negative, we still got to put that negative in front of it. Minus 6 times negative 3 plus 3. So guys, my rule of thumb is whenever you're plugging stuff back in for x, just put parentheses around that number and then copy everything else as you see it. You're just replacing the x. That way you don't have to worry about missing a sign or anything. What's negative 3 squared? 9. So 9 times negative is negative 9. What's negative 6 times negative 3? Positive 18, and then bring down the plus 3. So negative 9 plus 18? 9 plus 3, 12. So my max value is 12. Because my vertex would be at the point negative 3, 12. Now, we can still find the domain and range without actually seeing the graph, because what I say the domain of any quadratic always is? All real numbers, so negative infinity to positive infinity, or all real numbers, whatever. Range. So first off, think about it. We always use the vertex, the y value specifically, with range. Now, depending on whether the vertex is a max or min, depends on how we write the range. So we said the vertex is going to be a max. So does that mean that that 12 is going to be our biggest y value or our smallest y value? Biggest. So if we were writing it in interval notation, all right, would it become first in the interval or second in the interval? It's second, because remember, you go from least to greatest. All right, so the 12 would be over here. What would go to the left of the 12? Negative infinity, because remember, if you're looking at the overall shape, 12 would be up here, and then if the lowest would be all the way down here at negative infinity. So guys, if you can't visualize that, just draw a quick sketch of what it looks like. You know it's going to look like a max, so it's going to be an upside down U. And then just use that to kind of visualize what's going on. And again, you can also write this as y is less than or equal to 12, either way. Any questions? So again, if it ever asks you for the max or minimum value, they're talking about the y value of the vertex. All right. All right, last one. So number 1, this is kind of a reasoning problem. So they gave us a graph of a quadratic, but they did not give us the equation for it. But they gave us enough information in the graph to kind of deduce which equation could possibly represent the graph. All right, so let's just talk about things that we already know. Based off of what you see in the graph, what is something that's clear that we already should know? Richard? It's not 2 or 4. Why? Because it's a max, so that means what? What? It's going to be negative. A is negative. So since we have a max, or it opens down, whichever way, that means we have a negative A. So 2 and 3 are out. Not 2 and 3. 2 and 4 are out because they have positive A's. Did you have a question? Okay. All right. Now, what other key feature can we automatically tell from the...
On y, it's -5, and that's clearly not -5.
Right. So the y-intercepts as well, so the c values. Now, look where the y-intercept is on the graph. It's where? Is it going to be positive or negative? Positive. So if the y-intercept is positive, that means our c value has to be positive. So which one's the only one that's positive? 3. So 3 is the graph that would most likely fit the one that's graphed there. All right, any questions on any of this? Okay, so y'all got a solid 30 minutes. You should be able to finish that delta math from yesterday that I assigned. If you already finished it, by all means, work on your journal. All right. But you should be working on something for this class. Yes. Yeah, you can write your name on the board. So, guys, remember, don't get comfortable always using Desmos because, again,